Hello and welcome to factoring when there's a difference of two perfect squares. This is going to show a factoring method when there is a perfect square minus another perfect square. Remember that a perfect square is a number or an item that you can take something times itself to equal the perfect square. So 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. So that's what we're looking for. If we can find a perfect square minus another perfect square, it'll factor very nicely for us. We looked at these in the form like this already, where I've said, okay, we are missing the middle term. So the middle term is really 0. So if we were going to do our diamond, the negative 4 goes in the top and 0 is in the bottom because there's no middle term. And so the things that multiply to be negative 4 and add to be 0 are 2 and negative 2. So we've gone to our answer x plus 2 times x minus 2. And we've learned how to do it this way. But the reality is that because x squared is a perfect square and 4 is a perfect square and they're being subtracted, it falls under this category of difference of two perfect squares. The square root of the first is x, so that's going to go here and here. The square root of the 4 is 2, so that's going to go here and here. And one of them is positive and one of them is negative. So it's always going to follow in this kind of a format. If this was the first perfect square and this is the second perfect square, the thing here is going to be the square root of the first perfect square goes here and here. The square root of the second perfect square goes here and here. Now that's not square root of the number 1 or the number 2, that's the first item and the second item. Like this, 9x squared is a perfect square. We know that 3x times 3x equals 9x squared, so the 3x's will go here. 64 is a perfect square. We know that 8 times 8 is 64. One's positive, one's negative. All done. This one, 25x squared, is a perfect square. 5x and 5x. 49 is a perfect square. 7 and 7. One positive, one negative. Now the reason why this works is because if we were to FOIL this, we would get 25x squared, we would get negative 35x, positive 35x, and negative 49. And if you notice, these middle terms, negative 35x and positive 35x, those cancel, those make 0. And I'm left with just 25x squared minus 49, which is what I started with. So it works when you've got one positive and one negative, and when this last term is negative, because the middle terms cancel out. But that would not work if the problem was positive. If this was plus 49, then we couldn't have opposite signs. We'd have to have plus, and that would make this plus, and that would make this 70x and not 0x, and it wouldn't work. So if you ever see a perfect square plus a perfect square, probably we certainly can't factor it this way. It's probably going to be prime. Okay? Now also, we always need to check to see if there's the greatest common factor first. Like in this problem. 81 is a pretty big number. 900 is a pretty big number. I can divide a 9 and an x squared out of both of these. So if I do greatest common factor first of 9x squared, that leaves left over 9x squared minus 100. And now those are both difference of perfect squares. So this can go to be 3x, the 10, and the 10, one positive, one negative, and my GCF comes down in the front. On this one, I could divide the greatest common factor of 2 and m out in the front, which leaves 49n squared minus 100. And now this is 7n, 7n. Here's my 10 and 10. One's positive, one's negative. Here is my answer. Okay, something like this. There's a greatest common factor here of 2x, leaving left over 16x squared minus 25. So that gives me, square root here is 4x, square root here is 5, one's positive, one's negative. Lovely. And this one I wanted to show you because most people are aware that this one is a perfect square of 3x squared. But when you see the 4y to the 6th, that throws a loop. Is y to the 6th a perfect square? Does something times itself equal y to the 6th? Remember our exponent rules. When multiplying common bases, add the exponents. So if we have y to the 3rd times y to the 3rd, remember that's y times y, which is y to the 6th. So 2y to the 3rd times 2y to the 3rd will equal 4y to the 6th. One needs to be positive, one's negative. That is how to factor using a difference of two perfect squares. Have a great day.